In a previous problem, we found the kinetic energy of a brick being thrown to be 459 joules. In this video, we'll be using this value to find out if the person standing below skull will be fractured. I'll be referencing this document for the ultimate strength and the strain. It's worth mentioning that this is going to be a ballpark estimate, so it's going to be oversimplified. From this document, we get that the average skull thickness is about 6.9 millimeters. The sample has an ultimate strength radially, which is projected inwards towards the center of the skull, of 73.7 megapascals, or newtons per meter squared. Recall that the ultimate strength is the point where the max amount of stress the material can handle happens. This can be plotted in a stress-strain diagram to show the different phases of the compression of the material. Typically, the point of fracture happens at a lower stress level, but at a larger strain than the ultimate stress. The fracture strain, which strain is the change in length over the original length of the material, was measured when the sample fractured or failed. This value was pulled from the stress-strain graph and it is equal to 0.15 and is unitless. Now recall that force times the distance equals the work in joules. And also recall that strain equals the change in length over the original length. So the strain times the skull thickness equals the change in length. We want to get this distance, which is basically the amount of compression distance to fracture. Plugging in all of our values, we get a force of 443,000 newtons. This is the average force dissipated over the fracture distance. The fracture distance works out to be about 1 millimeter in case you're wondering. And also just keep in mind that this is a rough calculation. Now recall that pressure, which is our ultimate stress, is equal to a force over an area. Our area is the max area of the brick needed to fracture the skull. Rearranging this, we get the force divided by pressure being equal to the contact area of the brick needed to create enough pressure to fracture the skull. Any area less than this will create enough pressure to fracture the skull. We get an area of about 60 centimeters squared, or about 9.3 inches squared. Thinking about the shape of a skull coming into contact with the flat brick, it is well within reason that the brick would travel a distance of 1 millimeter and have less contact area than 9.3 inches squared. Think about a 3 by 3 inch square. So I would think with confidence that this would fracture the skull. But also to reiterate, this is an incredibly simplified version of this problem, and it's really just an approximation. So you can rebuttal this methodology in the comments down below if you disagree with it. That concludes this video. Hope that I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.